Here's an example of using U substitution in a definite integral. So this is one where we have the numbers, the limits of integration, and so this is one where the interpretation would be the net area between the x-axis and the graph of this function. And at first glance this looks just awful, but as you've seen in the other problems, all of these problems have been selected to kind of work out as nicely as they can. So, so when we have a fraction like this, a good choice for you is to let u just be the denominator of the fraction that you see. The reason for this is that having a fraction can be messy with derivatives and antiderivatives, but when the denominator of the fraction is just a single letter, then we have a lot more options. And so in the spirit of wishful thinking, we could say, well, this integral may not be too bad if it was something over the single letter u rather than something over this god-awful looking thing. So this is a good thing to try, and I believe all the ones in the homework that have fractions in them. Is that true? I don't know. Most of them anyway. If it has something messy in the denominator, then letting u be the denominator is a good choice. So from this, we then say the derivative. So the derivative is denoted du over dy. This is the derivative with respect to y for this thing. So it's always du with respect to whatever the variable is. So in this case, it's y. Anyway, so this is just the normal derivative. So the derivative of 7y cubed is 21y squared. The derivative of 9y squared is 18y. And the derivative of 9y is 9. But we want to rewrite this by multiplying both sides by the dy part of that expression. So that means that we'll have du equals 21y squared minus 18y. It's supposed to be a y. 18y plus 9 times dy. So in this notation here, I'm just basically saying I can multiply both sides by dy. So I have du left on this side, and on this side I have all this stuff times dy. And so these are the two substitutions that I get to make in this thing. So the first thing is what I can put in where I can place u in place of something messy, and the second thing is this to complete the substitution based on the derivative information. So instead of having 21y squared minus 18y plus 9, all this over this stuff, the entire reason that I made this choice was so that I could replace the denominator by just the letter u. And I still have dy. So I could make part of the substitution, the part that I was sort of shooting for, which was to turn that into something nice. This now has mixed letters in it, mixed variables, has u's and y's in it, and so I'm not going to be able to do anything with this until I get it to have just one or the other variable. If you look at what's left here that has y's in it, I have all this stuff in the numerator times dy. So all this stuff times dy. All of that's what's left in this problem that hasn't been substituted yet. But if you look above, this thing has been entirely gamed so that you have exactly what you need. So this stuff times dy is exactly what you see here on the right-hand side. And so that stuff is really the same as du. So this is the integral of just du over u. Now, the limits of integration, don't forget, this is the part that we have to deal with in this problem that did not come up in the previous problems, is that the limits of integration here are also in terms of y. Since the variable in the original problem is in terms of y, these numbers are referring to y values. So if I'm going to change this integral, the one I have at the end here, so that I have only u's in it, then this part, the thing that's being integrated, has been changed into only u's. But these two numbers, 0 and 6, are still going to be in terms of y. So to complete the substitution, I can say, well, when y is 0, what is u equal to? So when y is 0, what is u equal to? And this first substitution equation is what tells me that. So if y is 0, this is 0 minus 0 plus 1. So if y is 0, u is 1. In this problem, a little more complicated, definitely worth a calculator. Getting the calculator out, what did I get? Yep. If y equals 6, then putting 6 in here, 7 times 6 cubed minus 9 times 6 squared plus 9 times 6 plus 1. That's a big number. That's going to be u equals 1,243. And so now this integral has everything replaced by u's. Notice that if we didn't have a definite integral, if there were no numbers here, then we wouldn't have to do this last part where we also have to translate those numbers. Okay, so how do we do this? Well, the antiderivative of du over u is just natural log of u. So natural log of u gets evaluated between 1 and 1,243. So we have natural log of 1,243 minus natural log of 1. So that's the exact answer. Of course, log of 1, natural log of 1 is 0. So in some sense, that's not really there. So it's just 0. And so the answer here is a natural log of 1243. Notice that in this problem it asks you to round to 4 decimal places, so that means they want you to put this into your calculator and then just type the number rounded correctly to 4 decimal places there.